Here. So this is week 14, and this is the last week when we have some new topics coming in. Next week we have the final, not the final, the third exam. I have posted a document under exam 3 that tells you what will be the nature of questions on the exam. There will be 3 programming questions and about 10 multiple choice questions. Otherwise, the ground rules, everything are the same. The 3 programming questions, 1 will be on the drawing program, 2 will be on the finite state machine. So please read that document, and that will be the exam next week. It will be for about 3 hours, just like the other 2 exams. And tonight, as you know, I am offering a makeup exam for those of you who want to try and improve your score for the first question of the second exam. It is on the library system, as you know. I think I told you that before as well. And we will have 1 hour and 15 minutes for that question. So I'll be closing all the class exercise rooms at 8 o'clock promptly. And of course, if everybody is done by then, I will begin the exam a little early, and it will be for 1 hour and 15 minutes. But in any case, I will be closing the the class exercise rooms at, that is the breakout rooms, at 8 o'clock, and 8:05 we will start the exam. It is a makeup exam. You don't have to take it. If you get a better score on the first question than you got in the second exam, I will replace your score. Okay. So that is what I wanted to say regarding that. And this week, we are looking at some theory behind object-oriented design. So let me spend a few minutes summarizing what is in the PowerPoint, and then we will begin the class exercise. Let me get the PowerPoint up. Okay. And this is the first topic, proper subtyping. Remember, I am summarizing. I'm not getting into the details here, but I want to emphasize the main points. We have been using inheritance throughout this semester, and inheritance is one of the biggest advantages, biggest features of object-oriented programming. But if you create a subclass, you're adding more things to existing classes, right? You're changing the behavior or adding attributes, adding methods, etc. And you should have a good understanding of the superclasses to be able to utilize the subclasses properly. And this can be difficult. And when you create a subclass, you are creating a new type. And that can also create other issues. You all know that if B extends A, B is a subtype of A, and C implements an interface I, then C is a subtype of I. We know that. Apart from adding complexity to some extent, there are certain bad ways of inheriting. you obviously know that a stack cannot be a subtype of queue. You cannot have something like a class queue and then say stack is a subclass of queue, stack extends queue. You don't do that. Or you don't have, you know that there is an integer class in Java. You don't make button a subclass of integer. That is ridiculous, right? Or a list a subtype of string, or a member a subtype of catalog. There is no relationship between these things. The behavior is totally different. They are extremely offending to our sense of appropriateness. So that is not what you want to do, right? But sometimes you are not sure. Should square be a subtype of rectangle? Can you have a square extend rectangle, or rectangle extend square? Can periodical extend book, or vice versa? Or can set be a subclass of list, or list be a subclass of set? Then we don't know, right? Is there anything inappropriate about it? Okay, or is it perfectly fine? What do we mean? When is it inappropriate? When is it appropriate? Those are very difficult questions to answer. And that is what we are trying to address in this topic. This is the general idea. Suppose you extend class A and create a new class B. So A is already existing, and we are creating a subclass of A. The idea is this. If you create an object of type B, it must show some resemblance to A, because B is a subtype of A. So a B object should, in some sense, be behaving like objects of type A as far as the methods of A are concerned. Of course, you probably will be adding some new methods in B. You may even be overriding some methods of A, but there should be some kind of consistency in behavior. What do we mean? What is, I mean, it is still vague, but this is the fundamental idea. We have to make this a little more precise, and that is what we attempt to do here. So let's take this example, counter. It's a simple class. What it does is you create a counter and you can up the counter value. So it initially starts at 0. You can keep calling this up. It will keep incrementing the counter value. So you can get the value, and that is this field count. Initially count is 0. So if you look at the value, it will be 0. You can keep on incrementing up, 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 up. And if you do it 5 times, counter will be 5. And if you look at the value, it will be 5, if you get the value. And from time to time, you can say you are resetting it so that you can start counting from 0 again. A very simple idea. So there could be a program that uses counter. So this class counter is used in this client. And what it is doing is, it is in calling the up method to increment the counter for about 10 times. Okay. And it is doing something here which we don't really care too much about. It is doing some work 10 times by using this counter. All right. So this is a client. So it is in a loop here. If the value is less than 10, it is doing some work and then calling up so that it remembers that one more iteration has been performed. Very simple. Okay. Suppose we create a new class, counter2, which extends counter But let's say for argument's sake that we override the up method, and instead of incrementing by 1, we are incrementing by 2. Okay. So this count is being incremented by 2. What will happen to the client? Suppose we pass an instance of counter 2 here. Counter 2 extends counter. So any object of type counter 2 is also of type counter. So if you pass a counter 2 as the reference, as the object for this reference counter, then whenever you call up, it will be counting up by 2 instead of 1. So the work will be done 5 times, more or less, instead of 10 times. So the behavior of the client is now different. Instead of doing work 10 times, it is now only doing it 5 times. So the client would notice a difference when you pass a counter 2 object. So the behavior of the client is now different because it is getting a different object. Then we say this subclassing is inappropriate. So for all clients of counter, we should have the same behavior even if you pass an object of counter 2. What about this one? Public class enhanced counter extends counter. It has the additional method down. If count is greater than 0, it decrements count by 1. So it can count up as well as count down. Is this an appropriate subclassing? What do you think? Anybody?
Yes,
Yes.
it is.
It is. Somebody explain why?
Because you're not changing you're not changing the functionality of the already existing code. You're just adding to it.
Very good, very good, very good. So you, at least as far as this client is concerned, what is it doing? It is using the up method, and it isn't using down because counter is not supporting down. So it is not going to notice any difference whether you pass a counter 2 or enhanced counter or a counter, it doesn't matter. In fact, any client of counter, if it is using a counter reference, cannot be using this up because it is only supported in counter 2. So it would be a compilation error if you try to use down because it is not found in counters. There is no down here, so you cannot really use that over here. So this will not go wrong. In fact, no client will go wrong, of counter will go wrong. So this subclassing is quite okay. But things are not as straightforward as one might imagine. So it was Barbara Liskov sometime in the mid-90s. She proposed this idea. She gave a talk in a conference, and she said essentially this is essentially what she said. Talked about it for about an hour, and then this is essentially what she said. And I think at that time, she wasn't quite clear as to what the whole idea was. She just came up with these thoughts, and then later on, she made it more precise. And that idea is called the Liskov substitution principle. So that is essentially this. I'm not going to get into the details of this here. So subclass types should behave like superclass types. That is what this means. But then she hadn't made it precise initially, and she and another researcher, I think the other researcher was a graduate student of Barbara Liskov. They made it more precise and came up with a paper that is certainly the hardest paper that I have ever read. It is very difficult to understand it. I haven't fully understood it. I don't know how many people on earth have fully understood it. It is very difficult, at least for me. Okay, probably I understood 80% of it, but it's very hard. But you will get some ideas now through these slides as to what that paper's thrust is. Okay, look at this. So we are trying to introduce the main concepts of Liskov's substitution principle through an example. And we will also see some Java examples. And let me also add something here. I think some people in the industry are managers and technical people. When they interview students, they fancy asking questions about Liskov's substitution principle or LSP. So if you are ever faced with that question in an interview, what you should essentially say is this: it is about subtyping, and it is about the fact that when you subclass, the subclass objects should behave like superclass objects. And if they ask more, you could probably give examples of this kind. This would be an excellent example, actually, to give them some idea that you grasp what is LSP. Okay, so let's look at this. Think of a set. A set is a collection of objects. There are no duplicates, right? So we have a very simple class called set here, and there is a method called add. You can add an object. I'm not showing any of the code here. The idea is that if the object is not null, that is the precondition, before you call add, you must supply a valid object. You cannot call it with null. And if there is room in the data structure, that object will be added to the collection. That is a set. Very simple idea, right? Then there is a corresponding remove. If the collection is not empty, that is the precondition, some element of the collection is removed and returned. See, it doesn't say what to remove. It removes an arbitrary member. So there is code for it here. And it returns that removed object. Okay. Then there is a method to return the size of the set. How many elements are there in the set? There is no precondition. You can always ask what the size is. You don't have to have any objects in the set. It returns the number of elements of the collection. That is guaranteed. No matter when, you can call it at any time. That is what we mean here. Precondition means true. All preconditions are good. Or there is no precondition, actually. That is okay. Now let's see here. We have a class called list. It extends set. So every list is a set. Is this a good idea? That is the question. Then the question is, it depends. I mean, the answer is it depends. Public void add, we are overriding the add method. So the precondition is the object is not null. It is exactly the same thing as here. Object is not null for the set. But what does it do? It adds the object to the end of the list. Okay. Of course, this is what you want to add. And we are adding the object to the end of the list. Whereas for the set, it adds the object to the collection. Okay. Here the difference is it adds it to the end of the list. So is it doing something that a set will do? Or is it violating the set? Any thoughts on it? Is it doing something that is not consistent with a set?
I would think no, because set's not going to work correct if there's not something to be added, right?
Right. And your answer is correct. The thing is, the set can add the object at any place. It can add in the middle, it can add at the front, it can add as the third element, it can add at the end. It doesn't say where it will be added. It is just a collection. All list says is it is always going to add it to the end of the list. So the set could be doing that, The set doesn't say where it is going to add, so it could be adding at the very end. So this is not violating anything that a set is saying. So this method is perfectly fine. This override is perfectly fine. We are not violating any of the properties of the set. So this kind of an override is perfectly okay. This subtyping is not going to be screwed up because of this method. There could be other methods that you might violate, but this method is perfectly fine. So we are looking at the post condition and then saying, look, the object is going to be added to the end of the list. A set might be doing exactly that. You cannot simply distinguish between a set and a list because one object is adding things to the end. The set didn't say where it was going to add. So what if it was adding at the end? So this is perfectly fine. Remove. This says, the list says, I will always remove the first element. The set says, I will remove an arbitrary element. So this is also not inconsistent. The set could also be removing something that the list is removing. So this is also perfectly fine. So this override is consistent. So the list is still consistent with a set. And the size, it returns the number of elements in the collection. And this post condition is exactly the same as a set. So the list subclassing a set is okay. Essentially, that is what LSP says. This subclassing is perfectly fine. So we are determining it from the post condition. So the post condition of the list methods can be inferred from the behavior of the set methods. The list methods are doing something more specific, which is fine. Okay. So actually that is only part of verifying whether subclassing is fine. There is a lot more to it. It is very difficult to understand all the conditions that should be satisfied for subclassing to be okay. So we are not going there. We are simply looking at some aspects of LSP. So we are comparing the signatures. They are fine for the two classes. So what we are essentially saying is, if the superclass has a method M that accepts an object of type D, it is okay if the subclass would accept objects of type C, where C is a superclass, a super type. That is, it should be at least as liberal as the superclass method. If you are willing to accept an object here, it should also be accepted over here in the subclass. If you don't, then you will notice the difference. So that is one of the conditions. The overriding method should have parameters that are supertypes of the superclass method. Either there should be D or a supertype of D. And here is the return type. Here we have M. This is a superclass. It has the method M. It returns something of type D. And here, the subclass has overridden M, and it is returning objects of type E. If this were a super type of D, we would be in trouble. If E were a super type of D, we would be returning things that the superclass method wouldn't be returning. We should have D be equal to E, or D should be a super type of E, so that this never returns anything that a superclass method wouldn't return. If this returns something, it should be also possible to return it from the superclass method. So that is the return type. Here the return type should be a subtype, or the same as the superclass method return type. So you can actually have the compiler check these things. And that is what happens in Java. In Java, if a superclass has this method like this, D1, then the subclass, if you put at override by LSP, this can be D or a super type of D, but Java restricts it to D. So it is still consistent with the Liskov substitution principle, but it is restricting the behavior. So it is not allowing a super type of D. LSP would allow anything that is even a super type, but this only allows D. So it is consistent with LSP, but it is not going as far as LSP would go. I don't know why Java doesn't allow a super type of D. It is not documented anywhere. They must have had their own reasons for not allowing a superclass of D to be put in here in this parameter. If you put at override, the types have to be exactly the same. And for the return type, Java allows exactly what LSP would allow. So they are following essentially LSP, but with some restriction. It doesn't go, it is not as liberal as LSP. That is what I would say. Okay. All right. I think, as I said, Liskov substitution principle, LSP, is probably one of the most famous principles of object-oriented design, and you should at least have at least remember the basic principles of LSP. But there are a couple of other principles also that are probably going to be asked in an interview, potential questions. This is open-closed principle. This is much, much vague, more vague than LSP is. let's see what it is. What it says is, if you create a module, it should be open for extension and closed for modification. What it means is this: you shouldn't be changing existing modules, but to add new features, you should be able to extend it. And what it says is use inheritance. This whole principle was enunciated again in the 1990s when this field was at an infancy. So inheritance was considered a great thing. Nowadays, we take it for granted. So when we talk about open closed principle, OCP, it is not enough to just think in terms of inheritance. We should also think in terms of more elaborate systems. For example, look at some of the design patterns that we looked at, especially visitor and factory. Visitor, if you remember, the visitor design pattern allows you to add more functionality to an existing system without modifying any of the code in the system. So this is essentially saying we are not modifying this, we are not changing the system, we are not modifying the system, but we are still extending the system to add new functionality. So it is consistent with open closed principle. Or factory, we are not changing any of the existing constructors or classes, but we are adding new types and showing and having the ability to create them in a more seamless way. So we are able to add new types to the system using the factory design pattern. And state also, to some extent, it allows you to create new states to a system to refine the functionality, right? And also bridge. You see the drawing program, we had the bridge pattern so that we can add more and more graphical user interface technologies to the system. So that would be another example of OCP. And finally, the principle that we are going to talk about is SDP, the stable dependency principle. What this means is, in a object-oriented system, we will be creating multiple modules, classes or packages or whatever. Think of a module as either a single class or a collection of classes, whatever, some logical entity. If you have two modules, some might be more stable than the other in the sense you may not change something often. So if you have a module M1 and another module M2, look for the one that is more stable. Suppose M2 is more stable than M1, then M1 should be depending upon M2 and not vice versa. It's like building a house. The most stable thing in a house should be the foundation. If the foundation is not stable, you don't want to put walls on top of it, right? Because the walls will not be any more stable than the foundation. So the most stable thing should be the one that you depend on, right? So what it means is things that are more abstract in an object-oriented world will be more stable. So interfaces are the most stable things. So try to depend on interfaces than on concrete classes, because concrete classes might be changed. So depend upon abstractions and not concrete implementations. For example, look at this very simple idea of SDP. I have my list one. The actual type is new linked list. The declared type is linked list. Instead of this, use the interface list as the type of this list. So I have the second declaration here. My list 2 is of type list as opposed to linked list. The actual type is linked list, but the fact that I am using list as the type of my list 2 makes sure that I will not be using anything other than the methods of list. I cannot be using a method of linked list using my list 2. So list is more stable than linked list, and my list 2 is going to be more stable in that respect than my list 1, because this is depending upon it being of type linked list, whereas this is depending on list. If you want to change the actual type of my list 2, you can simply change this to say array list, or maybe vector. I think vector also implements list. So you are free to change the implementation without changing the declared type. So this is more stable. You can also define stable dependency in terms of packages. For example, the drawing program has a number of packages, right? And some packages are more stable than the others. For example, the shape package, it probably depends upon very little that is outside of shape, right? So even if other things change, the shapes package will not be changed. Okay, you can probably check that in the source code. What are the classes that the shape package classes depend on? And if they depend only on the shapes package, even if other packages change, the shapes package is going to be unaffected. So it is going to be more stable. And if you can figure out the stability of various packages, you can decide which ones to test first. The most stable packages, they may not depend on anything else. They can be tested first. Then you test others that are depending upon these stable packages, etc., etc. So it gives you a good way of testing stuff. And in fact, if you know your design pretty well, you can even decide how to develop, rather implement those packages. The stable ones can be implemented first. Then you can implement things that are dependent upon these stable packages, etc., etc. There are some details of couplings between packages here. And this is what I just said. I mean, you can develop and test the stable packages before you develop and test the less stable packages. Okay. That is essentially what I wanted to say here. Any questions before we go and do the class exercise? All right. Okay, let me then create the breakout rooms.